Fleming's right-hand rule. The following setup can be used to demonstrate or determine the direction of induced current in a straight current carrying conductor. In this case, we have a straight current carrying conductor between two magnets of opposite poles, the north pole and the south pole, also connected to a galvanometer, which is basically used in determining the direction of the induced current. We move the conductor upwards and downwards to determine or observe what happens on the pointer of the galvanometer. So the observations are as follows. When the wire is moved upwards, the induced current flows from A to B. So moving the conductor upwards implies that current flows from A to B, as can be observed on the deflection of the galvanometer towards the right. On the other hand, when the wire is moved downwards, the induced current flows from B to A. This tells us something about the direction of current with respect to the field created between the poles of the magnets. All these can be summarized into a simple rule which we also call Fleming's right-hand rule or the dynamo rule. So Fleming's rule is also known as dynamo rule. Dynamo rule or the Fleming's right-hand rule states that if the thumb and the first two fingers of the right hand are held mutually at right angles, with the first finger pointing in the direction of the field, the thumb pointing in the direction of the motion, then the second finger points in the direction of the induced current. So these can be shown here in the diagram, that we hold the first three fingers of the right hand in such a way that they are at 90 degrees to each other. In such a case, the thumb will show the motion, the first finger represents the direction of the field, and the second finger shows the direction of induced current. In other words, we can put it down as if the thumb and the first two fingers right hand the thumb points the field, the thumb points the motion, first finger points the field, and the second finger points the direction of the induced current. This is in agreement with the Lenz's law, which shows that the induced current flows in such a manner that it opposes the force of motion. The force of motion in this case, due to motion in this case, can be predicted using the Fleming's left-hand rule. In such a case, the force will be downwards. If we use Fleming's left-hand rule that was studied in Form 2, the force will be downwards while the motion is upwards. That is what Lenz's law says. So in other words, we say that Fleming's right-hand rule predicts that the induced current must be in such a way that it produces a force opposing the motion of the conductor.